Alright guys, so in the previous lecture I uploaded, there was a little mistake, but not like a mistake, but there's a little mistake. Now, if you notice, we said we have various equations for both bases and acids, right? For both acids and base. And we said for those of acid, especially HA acids, right? We said the equation we are to use to get the ionized form. In this case now, to get the ionized form, we use 100 all over 1 plus 10 to the power of pKa minus pH. While the unionized form will still be the same, but the only difference will be pH minus pKa. Why we say we have BH plus acids. Now, these BH plus acids are also the base. This is like conjugate base of the acid. Are you getting it now? Conjugate base of the acid. That is the base. Or let's just say the base. Are you getting it? BH plus. That is the base. Is that okay? Now, this base, I don't want to confuse you further. Just know that that one is the base. We said the opposite is usually the case. So for ionized form, for this base will be 1 plus what? 10 raised to the power of what? pH minus pKa. While the unionized will be pKa minus pH. Now the question is, how do you identify, right? How do you identify if the compound in question is an acid or a base? How do you identify that if the question given to you or the compound is an acid or a base? Now, in most cases, the lecturer want to be lenient. Normally, they are supposed to give us that this is an acid. But for PharmChem, they decided not to give us the acid, whether it's an acid or a base. But then, they give us a very important information that will guide us as to whether to choose if it's an acid or a base. Now listen, what I actually did initially was based on the information provided in the material, where he said pKa values. He gave various pKa value. Then he talked about acid, base, weakly acidic, very weak acid, and so you can't use that information to get the correct answer to this one. Is that okay? You can use that information of pKa, pH to get the correct information. So how do you know if the compound given to you is an HA acid or it's a BH acid, which is also the base? How do you know if the compound given to you is an HA acid or a base? Now listen, HA acids are those acids that ionizes in water to release what? H plus. Are you getting it now? All those acids that ionizes in water to release H plus are what? HA acid. Now, the structure given to you, this is another form of Kumaro, right? If it undergoes ketoenantiomerism, you discover that this place here is actually an OH. The structure given to you, if you check the past question, is an OH. This structure here is an OH. Now, when dikumaro ionizes, it's more like warfarin too. When dikumaro ionizes, this OH here will ionize as H plus. So what you are going to be getting will be what? O negative. And then this one will what? Be H plus. So it means dikumaro is what? An HA acid. Is that okay? So it means the formula we are going to be using to solve for the ionized form for both pKa's. This was the mistake I made. For both pKa's, will still be what? This formula here. Not using this one for what? Base. For both pKa, the formula will still be this. So if we've already solved for the first one. If you solve for this second one now, which is 8.0, to be 100 divided by 1 plus 10 raised to the power of what? pKa will be 8.0 minus pH is what? 6.4. Alright, that will be 100 divided by 1 plus 10. 8.0 minus 6.4. What would that give to us? That will give us 1.6. All right, this will be 100 divided by 10 raised to the power of 1.6 plus 1. So we have 10 raised to the power of that. I think that will give us 39. That's supposed to be 39. 10 raised to the power of 1.6. Yeah, 39.81 plus 1 will give us 40.81. Now, when you divide 100 divided by 40.81, that will give us what? 2.45%. Is that okay? So that's basically how to solve this question. Kind of very easy, right? Now let's see the next one. So most times the structure will be given to you. I've ever wondered why that structure was even in that formula in the first place. Now the next one we have is a tricyclic antidepressant, which is what? Amitriptyline. Are you getting it now? With pKa of what? 9.4. So the pKa for amitriptyline was given as how many? 9.4. What percentage of the drug will remain in the unionized form in the acidic environment with pH? I think the pH is supposed to be 4. Let me see if I actually made a mistake. pH is supposed to be 4. Okay, it's actually correct. They made a mistake. So with pH of 4.0. So our pH is 4.0. Now, how do we solve this? Very easy. First of all, let us identify this compound here, right? Is it acidic or basic? Is it an HA compound or a BH plus compound? Now, if you look at this compound here, it does not have any hydrogen it can actually give out, right? But this nitrogen here can be protonated. Are you getting it? We can protonate this hydrogen. That means we can give it a proton. And proton acceptors, according to Brewster-Lawrence, are what? Are bases. So most times, listen, most times when you see nitrogen, they usually are bases. Is that okay? Nitrogen that do not contain hydrogen that can be given up. Are you getting it? So at the end of the day, you have this base. This is a base. Now, the reason why it is a base is most times when you see compound containing nitrogen, ammonia, NH3, they are weak bases. Are you getting it? They cannot give this hydrogen out. Is that okay? Now, a compound that easily give hydrogen out, you can say is what? An acid. So amitriptyline is a base. So we are going to use the basic form. For the unionized form for base, we say for the ionized form for base is 100 all over 1 plus 10 raised to the power of. Ionized form is what? pH minus what? pKa, right? For base. Why the unionized for base will be 100 divided by 1 plus 10 raised to the power of pKa minus pH for unionized. So that at the end of the day, you become 100 divided by 1 plus 10. pKa in this case is what? 9.4 minus pH is what? 4. So that if you solve this, it's going to give us 100 divided by 1 plus 10 to the power of what? 5.4. Is that okay? So this is going to give us 100 divided by 1 plus 10 raised to the power of 5.4. I think that will give us 0 point something something something. So 10, will give us a very large value. That is 25118.64, right? 25118.64. All right. So this plus 1 will give us everything together here will be 25118.9. So at the end of the day, when you divide what you have here by what you have under, becomes 100 divided by 251189, which is about 0.00039%. So what that means is about this 0.00039% are all ionized. So it means almost 99.999% are what? Ionized in solution. So that's basically that. Now, that is that for this one. So we said amitriptyline is a base. And because it is a base, you actually use that formula to determine it. Alright, so that is that. Are we talking about, okay, this percentage ionized, then this is percentage unionized. All right, now the next one, we have calculate the percentage of diazepam that would be in the ionized form in the stomach after oral administration of a single dose. Now diazepam is a base. You can see this structure here. Because of the nature of this nitrogen, they can easily be protonated. So diazepam is a base. So what do you think our formula will be now? Percentage unionized will be what? 100 for base, 1 plus 10 to the power of what? pKa minus pH. This will give us 100 divided by 1 plus 10. pKa in this case is 3.3. pH is 2. This will give us 100 divided by 1 plus 10. 3.3 minus 2. Minus 2 is 1.3. Is that okay? Now, this will give us 100 divided by, we have 10 raised to the power of 1.3, which is 19.95 plus 1, which is 20.95. So this is going to give us 100 divided by 20.95, which gave us 4.77%. So these are the forms that are unionized. And then of course, if they say the ones that are ionized, the formula become, because you are talking about BH, becomes 1 plus 10 pH minus pKa. Alright, and then percentage ionized here will be 10, pH is 2, pKa is 3.3, which should become 100, 1 plus 10 minus 1.3. So you have minus 1.3 or 10 raised to the power of minus 1.3, 0.050 plus 1. So this is going to give us 100 divided by 1.050. So you are going to say 100 divided by the answer you got. 100 divided by 1.050. That will give us about 95.23%. So that is the final answer, in such a way that if you sum this and this together, we are expected to get how many percent? 100, because this is 95.23 plus 4.77. If you sum them, 95.23 plus 4.77, it gave us exactly what? 100%. Is that okay? So that's basically how to go about this. Don't use the pKa to identify if it's a strong base or an acid, if the compound is an acid or a base, what you do is look at the structure of the compound given to you. The structure will give you information as to whether it's an acid or what, a base. Most nitrogen containing compounds are bases, and those ones that contain carboxylic acid, like aspirin. Aspirin, of course, from the name of aspirin, acetylsalicylic acid, you already know that one is what? An acid. Diazepam is a base. Dicumarol is an acid. It has the OH functional group attached to something like a benzene ring, right? Which can what? Ionize to form the almost something that looks like phenazide ion, but not phenazide because the other bonds are not complete there. So that's basically the little correction I want us to take. All right.